Okay, this is our last mini lecture for our calculations of enthalpy. The test is on Friday, meaning in 2 days. Since this video will probably be watched for a couple years, tests will be in 2 days. So far, we've talked about stoichiometry as a way to determine delta H. Any problems with that? We're good, right? Golden on stoichiometry. Calorimetry, y'all are working on your lab that's due tomorrow. We're going to be able to calculate the C of the calorimeter, or at least the heat that's lost given the C of the calorimeter, heat that goes to the thermometer, add them up, and get your delta H of the reaction. Flippy thing, given heat of formation equations, you can manipulate those, add them up or whatever to get a goal. And remember, that goal will either be given to you or not given to you. You might have to write it, but just know that you're using those things to find the goal. And today, our final thing is called Big Mama. If you look down here, here's Big Mama. She's in a moo-moo, and she's got a big soda in her hand and curlers in her hair. And we call it Big Mama because this equation is very common, and it can be used over thermochemistry through all the values, through entropy and free energy as well. So, let me just kind of give you the breakdown behind this. We can calculate delta H using Big Mama, but there's another way we could calculate delta H, which is a lot longer, and you already know how to do this. What I could technically do here, I could write the heat. These are heats of formations. So what I could do is I could write a heat of formation equation for each one of these with its associated kilojoules. So how would I fix this heat of formation? And then make this 1/2. So I could write a heat of formation, and y'all don't have to write this down. I'm just trying to make a point. We're making 1 mole of NaOH. It's good practice for us. So we'd need a 1/2 here and a 1/2 here, correct? And then that's it. I could take these 2 heats of formation equations and do the flippy thing and get this goal if I really wanted to. So I could find delta H this way, but that's really long, okay? Big Mama is just an abbreviation of this. So the reason we can do this, does anybody remember what delta H is, what kind of function? We call it a state function. Did I talk about that with you guys? Where there's multiple paths that you can take to get to what you need to get to. I didn't do the school thing. If here's WHS and here's your home, yeah, you could just go straight, right? Or you could go to Starbucks, then go to your friends, and then go back to Starbucks because you left your phone there, and then go to the library because you need to get a book, and then go home. Does your overall displacement change? No. So you can take multiple paths. Big Mama is just pretty much the short way. Okay? So given your heats of formations, you can just plug them into this equation, which is the sum of your products times the coefficient in the balanced equation minus the sum of the reactants. So it's products minus reactants. So that will be another way we'll be able to solve. So I'm going to go ahead and we're going to solve for this problem. Here, notice they give us your delta H's. AP has kind of gone to the point where they give you the delta H's you need somewhere in the problem or on the page or in a mini chart. Looking at the big charts is more old school. For your homework, you'll have to look at the big charts just because it saves paper and it saves time. It's just easier to look at a chart. And when you get to college, you're going to be looking at the big charts. Your professors aren't going to give you these delta H's. But just know on your test and on the AP exam and on any quiz, you'll be given the delta H's you need. So with this information, we're going to set up delta H of the reaction is equal to products. So we have 2 NaOH's. What's NaOH's? Negative 470 kilojoules per mole. Sum of products, so I've got 1 hydrogen, but hydrogen is a free element, so 0, minus the sum of the reactants. Can I not put the Na in there? Y'all be okay? I'll just do it. Plus 2 times liquid water is negative 286 kilojoules per mole. Here's the kicker. People make calculation errors on these constantly. You need to do whatever you need to do to not screw that up. So if you wanted to just figure that out, and then write them down and then add whatever. But this can be done in your calculator straight up if you use parentheses. All right, so what do we get? And let's get it to the 3. We're going to pretend that's 3 sig figs. 3 sig figs. Or no decimal places, actually, because we're adding and subtracting. So no decimal places. Positive or negative? Okay. Did anyone else get that? All right, negative 368 kilojoules per mole. Now, there's a school of thought that, oh, these moles, this is moles and this is moles and they cancel. That's correct, but that's not the AP school of thought. On the AP exam, they have this representing mole of the reaction. So for 1 mole of this reaction, that's how many kilojoules are given off. And within that 1 mole, I have 2 moles of this, 2 moles of this, 2 moles of this, and 1 mole of that. So just know that for any final delta H answer where you're doing the entire reaction, you need to put it per mole in delta G, delta H, and delta S, which we'll cover later. All right, let's do another one. This morning I went ahead and put these. These won't be in your notes, but I went ahead and put them in the presentation. So we're going to find here the delta H for the following reaction. We have everything we need. And so we're going to go delta H of the reaction is equal to products 2 times CO2 gas is negative 393.509 plus 3 times liquid water is negative 187.78. That's products minus we've got 1 ethanol, negative 277.69. And these are all kilojoules per mole. They didn't give us oxygen. It's a free element. Guys, they're not, on the AP, they're not going to give you a chart with a 0 in it. You have to know that free elements are 0. You guys have to know that on your own. So, with that being said, what is our delta H? Let's go 2 decimal places. Negative 1,072.67. That sounds like last period. Did y'all get that? Okay. Negative 1,072.67 kilojoules per mole. Okay. That looks good. So this last problem, not really any harder. Just a different way to use Big Mama. So in this one, it says the standard enthalpy of combustion to CO2 and H2O of cyclohexane is negative 329. Look at this equation. What is that equation? Define it. We've learned 2 types of reactions. This is the combustion, heat of formation of combustion. I'm sorry, not heat. It's the heat of combustion of this cyclohexane. So do you see how the number they gave us represents this equation? So the enthalpy of combustion, the heat associated with this equation, is negative 3,924. Do y'all see that? Yes? Okay. Now they want to know what the heat of formation is of just cyclohexane, of this little dude. Any ideas? Yeah, kind of reverse. You're going to use Big Mama. We have the delta H of the full reaction, right? We have heats of formation of these guys. The only thing that we don't have on the paper is the heat of formation of that cyclohexane, and we'll solve for it. You'll make that a variable. So our negative 3,924 kilojoules per mole is equal to products 6 times, I can't see it anymore. What was CO2? Thanks. Plus 6 times H2O liquid, negative 1 87.78 kilojoules per mole. Products minus, we only have one reactant that we need, 1 times X. That X is what we're looking for. We don't need to include our free element. So now you just have to know how to do algebra. So funny, I wish y'all could hear you. So the heat of formation of C6H12 is equal to those of you who are not actually punching this in, I suggest that you do it on your homework and make sure you can punch it in, because it's very easy to make mathematical errors if you don't know how to do it. Anybody? Let someone throw something out so we can have a starting point. Naira? Positive or negative? 436 point what? Okay, that's 1. Did anyone else get this? Yes. All right. If you didn't get this, you need to check your math. And that's what's going to happen on your homework. Don't just not get it and go, no big deal. Yeah, you need to match the answers, because these are very easy to make mistakes on. And your test, I don't think your test is super long. So because of that, you're going to have time to go check over all your calculations. So I want you guys to do that. All right, that's it for this unit.